This is the Average Guy Network, and you have found Cyber Frontiers, show number 53, recorded on February 18th, 2019. Here in Cyber Frontiers, we explore cybersecurity, big data, and technologies that are shaping the future. If you have questions, comments, or contributions, we do have an email address. We'd love you to have those, send those to jim@theaverageguy.tv. Although the real guy, the guy who really knows the answers to the question, just send it to him, Christian@theaverageguy.tv. Christian, do you ever get any email from the show? Anybody ever email you?
I do. Some listeners with a variety of spammy requests to include our link in your articles, so that.
But no, I mean like listeners. Do you ever get like?
Yeah, no, I get some listener feedback for sure.
Okay. Yeah, well, we want to encourage folks to do that. Give us some topics. If there's some things you want Christian to cover, let him know. Christian@theaverageguy.tv. You can find me on Twitter @jcollison, and Christian is @BorgWhisper. Don't forget theaverageguy.tv, both web and media hosting powered by Maple Grove Partners. Get secure, reliable, high-speed hosting from people that you know and you trust. Plans start as little as $10. That's both sides. That's media and hosting available. Great for podcasters. In fact, Christian, I was just talking to a podcaster today in Lincoln, Nebraska, and he said, who do you recommend hosting? Maple Grove Partners, the greatest hosting service you've never heard of. That's kind of the tagline that I say, that you've never heard of. And he was like, oh, okay. So you may be getting another call in adding someone else to Maple Grove Partners. So good work. If you haven't subscribed yet, do so. There's an easy way to do that everywhere you're at. Just subscribe. Tonight, we're back with Christian. Christian, we pulled off a podcast 2 weeks in a row. What's up with that?
I know, pretty wild times in 2019 in America.
All right. Well, let's see if we can make it 2 all the way through, and then maybe 3 in 2 more weeks. What are we going to talk about today?
Yeah, honestly, the only thing that really has caught my attention in a meaningful way since we last spoke was the major CVE announcement last week around Docker being exploited. More specifically, anything that uses a executable on Linux known as runc. So we're going to kind of walk through what that is, what it means, what does it mean for you, but I also want to do a little bit of a deeper technical dive in where this came from, how they actually did it, and what the disclosure looked like. So we're just going to kind of step through it piece by piece and see where that takes us.
All right, let's get it done. Go ahead and get started.
Cool. So this was pretty interesting from a media perspective, because whenever you see the word doomsday in news articles, you should either immediately be concerned or immediately be skeptical. In this case, it turned out to be both. I was skeptical when I read the headline and concerned when I finished reading the article. So the use of the word doomsday was probably, we'd give it like a 70% accurate rating. You know, it was like some respectable people use the word doomsday, but like in comparison to all cyber doomsdays, like I didn't think Dr. Doomsday was about to show up on me. Anyway, the report itself is out as CVE 2019-5736. So if you remember numbers for some reason and you remember nothing else in this podcast, you can remember the number CVE 2019-5736. That'll get you along the way of the rest of this conversation. And so this is actually, why is it called a doomsday? It's called a doomsday because cloud infrastructures and enterprise environments are very much moving to a containerized world. Well, what do I mean by container? We started with physical hardware long ago. Eventually, we got powerful enough servers and desktops that it's like, hey, wouldn't it be great if I could have these different environments virtualized? So we started virtualizing operating systems. And, you know, today, almost any average guy can drop in a ISO of their choice, spin up a different operating system that they want, and run it in a virtualized environment that runs on top of the physical host operating system. So virtualization, pretty crucial technology in the last 10 years of enterprise IT, period, full stop. And to this day, virtualization obviously continues to be a huge part of enterprise architectures. cloud paradigms, et cetera, to the point where it might be interesting to do an analysis on how many enterprise infrastructures are made up of more virtual hosts than physical, because it's increasingly probably a large percentage of the world finds themselves in that situation. Well, containers kind of came around at that 5 year ago or so mark, but really have only matured in the last 2 to 3 years. So containers, like, well, what does that mean? Sounds pretty similar to um, virtualization. Well, it kind of is. With containers, think of them as like the lightweight, bare minimum thing I need to run something that resembles an operating system. So it's not designed to be the full kind of virtual machine child operating system experience. They're much more designed to be these kind of lightweight images that utilize and take advantage of the native host in order to execute and perform functions. So just like a virtual machine runs on a hypervisor, which is a lot of hardware sitting on a physical host, and you run n virtual machines against that hypervisor, containers work in a similar way, where they share a little bit more. So it's, when you think about virtualizing an operating system, you're in essence virtualizing the entire kernel space, memory space, the whole image, etc., is running in its self-contained environment that interacts with the hypervisor. And from a security perspective, if we were to be concerned about how do I jailbreak out of my virtual box into the physical host, I'd be looking at what are vulnerabilities in the hypervisor, right? To kind of escape out of that localized memory. Well, with containers, it's a little different. And containers really started more on the Linux side. So this is when we talk about containers, this is something that really was adopted in Linux technology pretty early on, and many people didn't really come to know it until they came to learn about Docker and what Docker can do for them. Um, and for many respects, Docker is kind of seen um, as a little bit of sandboxing software. People might think of it that way, but it's really meant to um, give independent resources an opportunity to run in its own environment with its own processes while utilizing and leveraging features of the parent host operating system. So there's much tighter coupling and integration between what the container relies on in the physical operating system. It's kind of like um, the analogy would be a virtual machine is kind of like the child that's 30 years old now and living outside of the house. You can no longer declare him or her as a dependent, whereas the container is very much a dependent. They're never going to move out of your basement. They will always require some type of default care and feeding from you as the host parent or operating system. Um, and there's kind of four capabilities in the Linux operating system that make containers do some of their core operations. Um, Number one, there's a executable called capabilities. And this is, again, all these things are kind of included binaries with Linux operating systems now. The capabilities executable basically ensures that containers like Docker will have a limited set of capabilities by default, which makes a container the kind of root user of an unprivileged user. So what I mean by that is one of the great advantages of containers is that it really allows you to isolate applications and services that don't require a full virtualized host, but still benefit from having its own isolation and its own kind of least privilege model of file system security, process security, et cetera, et cetera. So that first binary, capabilities, is how many containers kind of secure and lock down user privileges and bring in the least privilege security model into containerization. The second binary is called seccomp, seccomp. And this blocks container processes from executing a subset of system calls that limit its what I call blast radius on the host environment. So again, remember that containers are much more tightly coupled to the physical operating system than what a virtual machine is. So what seccomp is really doing is almost acting like a whitelist and a blacklist of, here are things that I, the container, am never allowed to execute. And this is important because we don't want to give our containers access to make privileged system calls that may allow you to kind of jailbreak out of your container. The third binary is called namespaces. And this is really how the containerized processes are limited and given specific access to the host file system, right? So it limits visibility to the file system. It also limits visibility to other processes across that host container divide. And the last binary is called C groups. This really limits the types of resources that get assigned to a process within a container. So I might want to limit the amount of RAM that the process has access to, or the amount of CPU resources. All of these mechanisms are very customizable, very extensible, can allow for really any kind of subset of calls that you want to utilize. And for the purposes of much larger services like Docker, they're orchestrating and kind of abstracting away anything that you, the user, would have to do in interfacing with these commands, right? They're the fundamental underpinnings of software like Kubernetes or Docker. And also, before I go further, in the show notes, you'll find a link from Dragon Sector. And Dragon Sector is the original group that has followed the research and actually published the disclosure responsibly that led to the CVE. And then they did a very detailed kind of white paper style write-up of how they did this exploit. And so what I'll be stepping through much of this podcast is from Dragon Slayer's, or I'm sorry, Dragon Sector's blog post on it. So make sure to go check that out, because if you don't kind of catch the gist of what I'm characterizing here, it's a really great read. It's called Escape from Docker and Kubernetes Containers to Root on Host is what they titled the blog post. And I'll kind of recircle back at the end with that information along with some other tidbits. But as we're talking through today's show, want to make sure that we give proper attribution that as the original disclosures of the vulnerability, they had obviously the most detailed technical white paper of how it works. So we're kind of following through their white paper and trying to break it down so far. Before I go on, any questions to Jim?
Ken was asking if there's any performance differences between VMs and containers.
Yeah, definitely. So in many respects, you're still relying on the physical hardware of the box, right? But there's different levels of overhead and performance characteristics between a hypervisor and a container. So in many cases, the lightweight container experience might give you more direct IO, as I like to call it, to have better performance in certain scenarios. Virtual machine technology today has become very efficient. So I can't speak directly to what the performance trade-off is between the hypervisor approach and sharing these resources. But generally, kind of the lightweight approach to containers should maximize throughput for certain applications when configured correctly. And that's kind of the caveat, right? Is like you need to make sure that you're providing the right resource allocation to your container, and that it's running on a physical host that is correctly set up. But yes, if you have a production kind of Docker environment or container environment, you can outpace a VM in many performance scenarios. Because with the VM, keep in mind, you're running all these additional operating system processes on the host that you probably don't need, right? So you have to kind of account for that, account for the disk space associated with an image that's a full operating system. So you're using extra disk, you're going to be using extra RAM to run that full operating system. You're going to be using some extra CPU to deal with task scheduling, all that kind of operating system internals. So containers definitely abstract away a lot of that overhead, and then you're also getting in some respects, more direct tasking of the physical underlying hardware, so less indirection.
So containers really, the benefit, right, was that less overhead, but higher security, right? And I think that's why sometimes this is the apocalypse, right? Or the what was the term they used for the
Doomsday.
doomsday, right? Is that I think for the average guy, containers or Docker was set to be like, oh no, these are super secure, right? And I think that's why when they found this exploit, it was kind of like yikes, because I think a lot of people have depended on them to be very, very secure. And of course, when you find an exploit, so I think that's kind of the reason maybe for the overreaction. I don't know if that's over or not. I don't know. Is it? Do you think it's doomsday?
Um, it had the potential to be if it wasn't properly disclosed, and I think this is one of the things that was really fortuitous about this is the way this vulnerability was actually discovered was through a capture the flag competition. So it was actually like, yeah, we're gonna do this capture the flag event, which is anyone who's in cybersecurity, like you've participated in capture the flag events and other types of challenges, and so um, this was an inspired research task from one of the CTFs, and the CTF was called namespaces, and it was from the group 35C3 CTF. So they find this vulnerability in the process of participating in the CTF competition, and they were very much professionals about it. So the doomsday scenario would have been an improper disclosure or selectively leaking it to certain people to take advantage of it. And keep in mind that major cloud platforms and enterprises obviously host container images, allow you to spin up arbitrary containers. And the actual vulnerability we're going to describe today is how this particular issue allows you to escape out of the container into the physical host at what we call root level permissions, meaning you own the box. And obviously, for from the perspective of I could be running thousands of containers on a given physical host. All I need to do is grant one user the ability to share up and spin up and run their own container. And if they were able to use this vulnerability, they might be able to start rip roaring into other containers on that host or gain additional privileged access to the physical host itself. So in the case where you're a large IT organization and you're handing out Docker containers like candy for people to run and test their apps, like this could become a huge attack exploit for you. Now imagine the case where it's like the domino effect of vulnerabilities where let's say your container runs a web server and your web server is compromised. Like one point of the containers is, oh, great, the web server is compromised. At least they can't do anything other than hose the web server. Well, now they could maybe use some web server vulnerability to get into the container. Now I'm in the container, I can corrupt the container image and now jailbreak out. And ooh, look, now with one web vulnerability and one container vulnerability, I now own thousands of containers. So the doomsday is just that the cascading effect potential that this particular vulnerability has is very significant. And I think that's why it got the label that it did.
Yeah. Let's walk on through, give us some more details on this.
Sure. So we talked about those four capabilities, and those are to kind of frame this in the context of containers are king in the Linux world. So we're very much living in a Linux operating system right now. The team that was part of the CTF tried several failed approaches. And what they were really focusing on is, and this is again a quote from the blog, quote, investigating what happens when a new process gets started in an existing namespace, which many people know as the command docker exec. And so they're looking for all the different system calls that are associated with how a container operates in order to start to look for weaknesses and mechanisms to take advantage of those system calls. So they focused on several different areas that take advantage of namespaces. Remember, namespaces are the key mechanism by which the container has least privileged access to its own file system, file descriptors, et cetera, et cetera. So what they were looking for is mechanisms to bypass the security model of namespaces in order to gain additional access to more namespaces. In other words, breaking out of the container. So they looked at, so anyone who's run a Linux operating system, you know that /proc is kind of where a lot of the very low level aspects of system calls and hooks into the hardware exist, both from a statistics standpoint, from a input output standpoint, etc. So they looked at um, process identifiers for memory, for the actual executable itself, for Docker, for file descriptors and whether or not those file descriptors could be leaked from other namespaces, and also from file maps. So there were a list of 5 things that they really focused on and tried to look for vulnerabilities. And the intuition here was that they were trying to force the Docker exec command to basically dynamically load and link a known malicious binary that they get to control. And in the process of loading or side loading that malicious library, they were looking to overwrite that core proc exe reference so that they could also overwrite into the host's version of proc exe. And that was pretty much the generic attack approach. Now, there were specific failures associated when they first started the CTF. And there's this sysadmin capability requirement that they looked into pretty substantially. And without it, without that process, they really could not leverage the type of attack vector that they wanted. And that was specific to the map files proc. And I'll just direct quote it here. They found it was an interesting vector because, quote, before runc executes the target binary, but after the process is visible to us, all the entries refer to binaries from the host file system, since that's where the process was originally spawned from. Unfortunately, we discovered that we cannot follow these links without the sysadmin capability, even from within the same process. So essentially, when they're looking at the kind of the attack surface of what is the best thing I'm going to be able to leverage from /proc, they found that this map files was very interesting because it contained all of these references to binaries that exist at the host file system, right? So if we want to talk about like signs that the container is linked to the dependent parent, like this was it. But unfortunately, they didn't have that key capability in sysadmin to be able to kind of follow those links out of the container into the physical operating system. And they found a couple interesting side notes that are kind of more geek specific. So we'll drop them from the purposes of this conversation because they're not really about the exploit so much as strange quirks with the Linux kernel. Who would have thought? So eventually this leads them to the successful approach. And it is very similar to what I just described with respect to the attack vector of the map files process. But really they look to execute that proc self exe, which is the host Docker runc binary. And again, runc is maybe mysterious if you've never used Docker. It literally means run container. So like when you have a particular image that you want to spin up and run that container, runc, put in the image path, and you're good to go. So they wanted to be able to run C while still being able to inject some arbitrary code, which they managed to do by changing a shared library that they have control over to execute that code inside a global constructor. So what that does is gives them the ability to overwrite that exe in the parent host. then giving them full capabilities and root access on the host the next time the runc command is used. So it sounds a little confusing over a podcast format. Let me kind of try and reframe it again. So we have map files. We are looking to basically, as the attacker, my attack vector, the assumption being made here is that I already have access to a container, whether I have that container because I'm authorized to use it or because I exploit that container, whatever. I, the attacker, am living inside the container. That means by definition, I have access to manipulate any of the resources that are a part of that container, whether it's a core process resource or file system resource, whatever. And so what I'm looking to do is create a kind of like a globally linked library where I can inject my evil code and then trick the runc binary that any Docker operator would use to loading that malicious library. And then that malicious library is taking advantage of the relationship of how file descriptors are used in map files in order to overwrite the contents of the physical host's executable with known badness so that the next time someone uses runc on the physical host, they will be granted full access and root level access the next time that command is executed. Are we with me so far?
Yeah, no, I think that makes sense. So they would run the next run C, right? That's the idea. So you
Yeah,
set
that's right.
all this up, and then a malicious attacker would do the run C, gain access to the containers, and then really be able to do just about anything they want, right? I mean, they would have.
Yeah, well, and so it's specifically like root access to runc the next time it operates. So it's unclear to me where you privilege escalate from there into the host, um, or if it's just now giving you basically an unfettered mechanism to continue permeating through other containers. Because now that you have root level access to runc, you can start trying to guess other containers, or maybe you know what those other container names are to load them and access them, right? But if you think about container structure, like runc is a very privileged process. So if it's running with UID 0 on the host operating system, yeah, you're absolutely right. I can pretty much go anywhere from there if I've gained that level of privilege.
Christian, how important then is, as we think about these capture the flag, these events, these hackathons, these events, I mean, how important and how often do we run these where it sounds like to me this was kind of an open invitation, like, hey, find some things in here, right? I'd imagine in that world that's pretty important to for this very reason, to let some folks hack on this thing to find these things before you get the malicious person that finds it, right? And is it found in what is it found more that way where it's kind of it's in an encouraged way as opposed to it being found in the wild by maybe a malicious hacker?
Yeah, so I mean, researchers, cybersecurity researchers, and otherwise are constantly kind of mulling over and build it, break it, fix it type deal. Whether that's done in a structured activity environment like capture the flag or an unstructured environment, I actually think the CTFs are by and large a very good thing because you're bringing together a lot of sharp minds to work in a team environment as opposed to maybe an independent researcher environment. Oftentimes CTFs are done in groups as opposed to individual competitors. So the likelihood of cross collaboration may increase the probability that you find something, right? But the CTFs are they're very broad in the sense that they'll give you topic areas to focus on, or like, hey, the CTF's going to be focused on this area. And some cybersecurity competitions, for example, like you're going to be able to quote pull off the exploit or pull off the heist, right? Like they're designed to see how many challenges you can work through, and work through things that will have known flaws in them for the purposes of the challenge. Other types of CTFs like this one, it's more like we give you the topic area, the things that seem interesting, but there's no assumption or assertion going in that, hey, we know this thing is vulnerable, right? in this CTF, we had no idea, obviously, that Docker and container libraries had this type of vulnerability, right? But because they started researching in the area that was proposed by the CTF, namely, hey, why don't you do some more research on namespaces, which is a core underpinning dependency that containers take on, they then were able to kind of work their way through this research process and stumble on what ultimately became the disclosure. And again, if you're participating in a CTF, like and in a team environment, chances are, I think there's a very strong correlation between that and responsibly disclosing it, which is what happened here. Whereas on the contrary, you're a shady actor working by yourself or working with a group of underground shadies, and you're not doing it in a competition environment. And when you find something, you're immediately looking to exploit it for fun and profit, as opposed to do responsible disclosure.
So, one of the things I was a little surprised as I'm reading through this doc, there's an area that says responsible disclosure, and they talk a little bit about the way they disclose this, and just like it strikes me a little odd that it's all done via email. You're like, don't we?
Yeah.
In the security world, don't we have kind of and not saying every little bit of email is insecure, but you're kind of blasting out a major exploit on something across a system that doesn't have the best track record.
I mean, it's a great call out. Now, like what we don't know is, were they using PGP to encrypt the email when it got sent to Docker team? Like what types of encryption was put in place when they sent the email? But I by and large agree that email is a very odd form, but that is the majority of how these types of disclosures get reported. My hope is that, and I'd have to do some digging to know for sure that, responsible disclosure involved in this case, find the PG, and that's a two-way street, right? Number one, in order to properly encrypt the email and send it to them, Docker and their reporting mechanisms need to have their public key published and available for their abuse and or vulnerability emails, so that people know who to encrypt it to. So there's the responsibility on the person writing the email, and also the responsibility on the organization to be like, hey, here are encrypted and secure ways to get in contact with us. And actually, journalism, this is a fascinating area where I think journalism in some ways may be a little bit ahead, because many journalists, if you dig down into their about section for like big newspaper or investigative reporting organizations, they'll have like a list of 10 different ways you can kind of anonymously and securely drop them information. They're on Signal, they're on this app, they're on that app, they have this key. So they kind of create these 6 ways to Sundays channels to maximize the potential that someone feels confident that they can securely share information. I don't know if we go through that level of investment in customer experience in this respect, specifically from like the responsibility of responsible disclosure probably says, okay, give one main avenue to do it. But journalists, no, they have like 20 different ways to do it. It's quite interesting.
Well, they're incented in the right way, in that like these are people's lives, and I'm not saying, I'm sure, like I am almost positive that there's more went into it than send an email to security@docker.com. Like,
exactly.
I'm positive, but it's funny reading this. You've got this really sophisticated document, and then it's like, so we reported the vulnerability to security@docker.com, and then it says they the next day they forwarded the email.
Yeah. Well, and so, the other funny thing too is, most people don't realize that when Meltdown and Spectre happened last year, right? After that became public disclosure, there was, whatever the very initial mitigations were. If you want to talk about an ancient communication mechanism, and this is how just the Linux kernel foundation operates today, they operate over like classic old school 90s email list boards. So like you can go watch Linus Torvalds, who is, founder of Linux kernel, go and tear someone a new one on like a public wide open email thread with like very well respected engineers and other folks. And you can just watch like Linus rip someone a new one. And so if you, and anyone can go and subscribe to these things and you can read some absolutely fascinating conversations. I was subscribed for about 3 months from the time the Spectre and Meltdown hit to about 3 months after. I subscribed to an unfiltered view of the kernel distro conversations where there were major back and forths across hundreds of developers around okay, we have these initial mitigations. They are absolutely terrible from a performance standpoint. What are we going to do to kind of keep raising the bar and making the kernel more robust and handling this type of concern? Well, I think I had close to like 1,000 emails a day just from that. And obviously it was a very busy time because of the scope of basically saying, we're dealing with the fact that we drove a truck through the kernel and now are just kind of slowly reacting. But in those initial months, I mean, I think by the end of my experiment, I had close to like 24,000 unread emails in my inbox specific to just subscribing to that public distro. So like it was the major vehicle for how all these different industry organizations kind of got on the same page with getting their 2 cents in about how the public open source Linux kernel should react in an official code base perspective to the Meltdown and Spectre vulnerabilities. So, you want to talk about an ancient mechanism, like that's it. And apparently it's still one of the most effective ones. Otherwise folks wouldn't be using it the way they do. But this one smells a little bit different, right? Like Spectre and Meltdown, there's a lot of work that went into this one. This one probably had a very different responsible disclosure timeline than Spectre and Meltdown did.
Well, you get the feeling sometimes too that when you debate this openly, it's like hiding your secrets in plain sight, and that adds some credibility. I mean, yes, it is an enormous effort to weed through all that dialogue and the debate, but there's oftentimes in that there are gems of truth. There are ideas that are the right ideas that need to be argued out. They need to be debated, and they need to be. The way we go about debating them isn't always healthy.
Yeah.
Right? It's not always cordial. But I think especially in some of these matters, it's important that they get all this stuff out. And yeah, you're gonna get some crazy folks who don't know how to interact in public like that, but they still get to the truth, I think, in a lot of cases, and not always perfectly. Right? We're still a human process. And there may be vulnerabilities found later in some of those things that they discuss publicly. I think sometimes we think open source is always perfect because it always has so many eyes on it. Well, it still has a lot of imperfect eyes, and it's not always checked every single, and you don't know what you don't know. And so, but that kind of chaos is healthy. I think it often creates clarity.
Mm-hmm.
And so it's not a bad process. This one though, I mean, this really does sound like is you're going. I haven't seen one like this where it's pretty calculated and controlled all the way through the process to get it done. So they've discovered it. They announce it. What happens next?
Yeah. So, and two, I just want to capture real quick. Again, you can read this in we pretty much covered it, but when you read the detailed attack description in the blog, it'll give you kind of like the full A to Z of where they did the entry point into the binary, where they created the symbolic link, how they actually sideload that evil code, do the overwrite of the host's version of runc, and then go on from there. So where do we go from here? The initial response was pretty good. There were some assumptions that needed to be made on how what configuration you were using in order to be able to leverage this vulnerability. Right? We talked about some of the attack surfaces that allow this to work in this configuration, but you have to have some assumptions about who the malicious user is and what is the configuration of the production environment. So the quick reaction was, I think the day that it was responsibly disclosed, the major vendors that were impacted by this pretty much immediately published in tandem, hey, we've addressed this vulnerability. Here are other things that you can do. This obviously involved publishing and creating new container images to be available for download that didn't have the exploit. There were also, though, some like hot quick fixes that folks could use. One is that if Docker containers are used with SE Linux enabled and everything minus Fedora, I think from what I understand, this prevented processes from being able to overwrite the host's Docker run C binary. So another win for why SE Linux is awesome, because even when there's 0 days, it can stop bad things from happening. Second quick mitigation was to use a read-only file system on the host. This is like I think that's a little bit more hacky one. You have to be in a pretty comfortable operating capacity to just arbitrarily apply that type of configuration in a production environment. And then the third one was to use a low privileged user inside the container or a new user namespace with UID 0 mapped to that user. So again, that keeps UID 0 from being allocated to a higher privileged user, which keeps the exploit from working.
And that's a pretty specific exploit block, right? Because the exploit takes advantage of that user 0, just take up the space. And
Yep. And in the end, the actual final fix, the actual mitigation to the vulnerability was that they create a memory file descriptor, which is a special file that exists only in memory. So it's like, again, file descriptor like you would on a hard disk in memory. And then they copy the original run C binary that you would expect to use to that file descriptor. And then before entering the namespaces command in Linux, you re-execute run C using that specific file descriptor. And what that does is guarantee that if an attacker overwrites the binary pointed to in the physical file system, it can't cause any damage to a host because the correct copy of the binary is running in memory, stored entirely in tempfs. So
and they don't have access to that space.
Correct. Well, and again, it's more like they don't have access to hijack the specific file descriptor. Like if you hijack the thing on the box, you'll still be able to hijack it, but now it doesn't matter because that is not the actively running executable, it is the reference executable. And it's kind of an interesting mitigation. It is very much along the lines of it's very much along the lines of I don't want to call it a workaround. It's not a workaround, but it doesn't exude much confidence that they're not going to find another type of future privileged aspect of containers that don't require the same type of side loading in memory in order to secure it. So I'm okay with it. I'm not thrilled about it. It's much better in terms of a straightforward vulnerability and response than Spectre and Meltdown was, right? Like that's stuff that happened at the level of hardware, had really terrible response levels in the sense that the initial mitigations were honestly almost worse than the vulnerability itself in some, specific use cases. So this is much cleaner end to end than something like that. But I think it's interesting. But it was ultimately nice that, there were short-term mitigations you could have used if the final fix wasn't available to you for some reason.
I'm assuming folks will go back. This will get mulled over again. Now that we're clear, we've got some mitigations in place. the community will go back and keep digging on this thing just to make sure, right?
Oh yeah, I mean, I'm sure people are making sure there are no variations on a theme here, right? And we saw that with Spectre specifically. That even after the initial 3 variations of Spectre Meltdown had been disclosed and patched, that people were testing additional variations of Spectre for months after, and some additional variations were found. So I would expect very similar things have been happening with this vulnerability, but to date, there's nothing to report in the to the effect of additional vulnerabilities from that research.
Well, and it's still pretty new, right? I mean, this was a vulnerability really discovered very first of the year, right?
Yeah, well, I mean, that's I laugh. It's like all big cyber whatever seems to crack on New Year's Day for whatever reason. It was very similar to how Melter and Melter, Spectre and Meltdown
That's
went.
the combination of it. Smelt.
Yeah, Melter, Schmelter. I like that. Yeah, Schmelter was like beginning of 2018, so I guess we had to have some big bang at the beginning of 2019 to get us all excited.
Yeah, we're
So
just
here we
50
are.
days into the year. So
Yeah.
I think it was 50 days away. That's, you
Yep.
know, yeah.
Yeah, not bad, not bad. And apparently the discussion of mitigations began like 2 business days after receiving that notification.
So
So,
sysadmins mostly move, right? To begin, they'll pick up on this and start to move on the mitigations pretty fast, right?
oh yeah, I mean, by and large, we're a week out from the public disclosure, so most large organizations should be well patched from this by now.
Mm. Do they know earlier than?
Yeah, so if you look at that timeline provided in the blog post, February 11th is the day that the embargo was lifted. So that means that Docker and the Open Containers Foundation worked in tandem with the biggest customers of those software platforms to make sure that they were included in the conversation and were already patched and ready to roll prior to it being publicly disclosed so that it's not some type of race to the clock to patch the 0 day.
Mhm. Yeah, no, super
So
interesting.
yeah, good stuff.
Yeah, man.
Exciting way to start 2019's day in cyber.
Yeah, pretty cool. Anything else you wanna say on that? Anything else you wanna add in there?
No, that's a wrap on that one.
All right.
A short outtake for the show, and this is an article that I'll post just because I found it interesting in my weekly reading. Was a small tidbit that came out today from a statistician that basically says machine learning is causing a quote crisis in science because um, folks don't have the ability to effectively measure reproducibility of experiments. And basically, folks who are poorly applying machine learning techniques in science and are getting certain results, and then they change to this much larger data set and find that the two don't agree, they very much realize that they can't reproduce the successful outcome because of too many variables that don't allow them to take that kind of mathematical hypothesis proof backed approach. Um, I just thought it was a very interesting anecdote on where we are headed in what I call quality assurance and verification of artificial intelligence. So,
All about trying to predict the weather, right?
yeah,
I mean,
yeah,
how long have we and what kind of models have we applied and all the things we've tried to do. Omaha is currently slated for 5 to 8 inches of snow tomorrow. We'll get a dusting, right? I have alerts on all my devices. Get ready, snow is coming. I'm expecting, half an inch because we still, I mean, there's so many numbers there. And yeah, I think the National Weather Service runs 4 or 5 different models, trying to predict this. And it still is a little bit of chaos in big data, trying to figure out who's going to do what and when and how are things going to happen. I imagine it'll only get worse as we try to figure out what 7 billion people on the planet are going to do. That
yeah,
it's a problem we're solving. So interesting. Well, you want to wrap it with that? Is that
yeah.
good?
That's a wrap.
Awesome. Oh, cool. Well, want to remind everyone, rate, subscribe, and review on Apple Podcasts. If you haven't done that yet, head out. Cyber Frontiers is pretty because we've been pretty sporadic. We really haven't had anybody do that. So if you're listening and you got a few minutes, jump out there, get that done. That's always kind of nice. If you listen to us on Spreaker, and many of you do, I'm really surprised. We get a ton of traffic that listen and download right directly from Spreaker. So if you're a Spreaker listener, follow us over there. Follow us on the channel, and that way you get notified whenever we put something out new. Don't forget, the Average Guy.tv is powered by Maple Grove Partners, secure, reliable, high-speed hosting from people that you know and you trust. He sits right across from me over there. And for more information and some great plans, Maple Grove Partners, all one word, .com. If you want to send in subjects for us to cover, or you like Christian to, and it's really Christian, let's just be honest, I don't know anything. If you have anything you want him to cover, send us an email, Christian@theaverageguy.tv. Find him on Twitter @BoardWhisperer. I don't know if I can say that right. I already moved on to the next sentence. If you enjoyed it, share it. We'd love to have you do that. We'll look forward to the next several frontiers. We'll do it again maybe in a couple weeks or a couple months. We never know. With that, we'll say good night.
Good night.